Hi everyone, in this video we're going to work on composing trig functions and inverse trig functions. So sometimes the result will be fairly trivial and other times it gets a little bit tricky, and I love this for a couple of reasons. One is that we have to think our way through some of these compositions in Calc 2. The other is that it really makes you think extremely carefully about what each of our trig functions and inverse trig functions do, what they input, what they output. Okay, so, oops, sorry for the wobble. First one, inverse sine of pi over 6. So really the first thing that I'm hoping here is just that you remember that when you compose inverses, you should get back what you started with. So I'm hoping that we all have a pretty, excuse me doing these at night. Okay. When you compose a function, its inverse, you should get back what you started with. So I'm hoping that we have a guess at least that we should be getting pi over 6 here. We do have to be a little careful. We have some pretty hefty restrictions on what inputs of sine we allow for the inverse thing to work, and consequently what outputs of inverse sine we allow, what arc lengths we allow it to give us back. So here we can even walk through and actually do the steps. I don't know that we have to, but just to make sure that we're being really careful. This is sine pi over 6. So pi over 6 is an arc length. That's what sine inputs. When I take the sine of pi over 6, I get back my y value, which at that point will be 1/2. If I then take 1/2 and plug it into inverse sine is going to say, oh, you're giving me y value 1/2, which is great because that's exactly what I was thinking when I got it out of sine. My y value is 1/2. And then inverse sine should tell me the arc length between negative pi over 2 and pi over 2 that does that. So I'm saying if my y value is 1/2, and I'm choosing the point on this side, what is my arc length? And it is in fact pi over 6. So it does work as expected here. When you compose a function and its inverse, you should get back what you started with. But again, there can be exceptions to this when we violate domain restrictions and things like that. Okay, so next one, I want to take the tangent of the inverse tangent of -1. So once again, I'm sort of ahead of time predicting in my head that it's going to be -1, but I can walk through really carefully. So if inverse tangent is getting the -1, inverse tangent will immediately assume that the -1 is a slope. Once it gets that slope of -1, it's going to output an arc length between negative pi over 2 and pi over 2. So if I'm thinking about being on the unit circle with a slope of -1, I could be in quadrant 2 or 4. That negative pi over 2 to pi over 2 restriction is going to force me over here. And specifically, I'm right smack in the middle, so it's going to give me negative pi over 4. So I say, if my slope is -1 and I find my arc length, and then I give my arc length to tangent and try to find my slope, what do I get back to? And it should in fact be -1 again. So still no weird problems. I swear they're coming, but none so far. Okay. Arc cosine of 5 pi over 4. So here I'm saying, okay, if I'm inputting it into cosine, the 5 pi over 4 is an arc length. So I'm picturing that I've gone 1, 2, 3, 4, 5 pi over 4. So I'm sitting in quadrant 3. I then take cosine of that arc length. Excuse the yawn, which is a -1 over root 2. Okay, so far I've said if my arc length is 5 pi over 4, my x-coordinate is -1 over the square root of 2. The next thing I'm supposed to do is decide what my arc length is if my x-coordinate is -1 over the square root of 2. But you want to be really aware of the fact that even though our cosine and cosine are sitting here right next to each other, they're not communicating at all. So our cosine isn't thinking, wow, we started at 5 pi over 4 to get this arc length. It's just thinking my x-coordinate is negative 1 over the square root of 2, which means I'm either in the middle of quadrant 2 or 3. Because I'm arc cosine, I'm going to throw away quadrant 3 and I'm going to say, okay, this is my point right up here in the middle of quadrant 3, and I want to pick the shortest possible arc length to get me there, which is a 3 pi over 4. So here's our first case of failure to communicate. Arc cosine and cosine are not actually inverses if you're working with an arc length that's not between 0 and pi. So if at any point you're picking up arc lengths that aren't in 0 to pi, you're in a little bit of trouble. It's doable. It's not that we can't do it. It's just that they're not inverses. So really what we ended up saying here is which arc length between 0 and pi will give you the same x-coordinate that you'd get with an arc length of 5 pi over 4. So we found the arc length that gives us the same x-coordinate that we had at this point. Okay, sine of arc sine of 1/2. So again, I kind of tentatively want to think that I'm expecting 1/2, but I want to be really careful because the trig functions and the inverse trig functions can be a little tricky. So I am inputting the 1/2 into arc sine, which means it's a y. So first question is, if your y coordinate is 1/2, what arc length between negative pi over 2 and pi over 2 did you use to get there? So I'm going to use this one, which is a pi over 6. Okay, so in here I have a pi over 6, and then I say to myself, so completely new start on this thing, if my arc length is pi over 6, what is my y coordinate? So this one is another one that works perfectly well. So let me think if I can talk through that one nicely. Find your y value if you're at the end of the arc length between negative pi over 2 and pi over 2 that makes your y coordinate 1/2. So you can see there that I hope that the restriction on angles didn't really make a difference. We were starting with a y value of 1/2 and we were asking what y value we would end up at, and since nothing in that process moved us to a new point, we're still going to have a y value of 1/2. Okay, let's see. So we want to look at a cosine of an inverse cosine of a square root of 2. So the square root of 2, since I'm plugging it into inverse cosine, that's an x value. So I'm saying if my x value is square root of 2, what is my arc length? And this is one of those, again, that's undefined. We can't even actually make it to that second step. So just think carefully, right? It's really tempting to say cosine of inverse cosine of square root of 2 is square root of 2. But if this inner question doesn't even make sense, you can't do that. And also, if you get anywhere outside of those negative pi over 2 to pi over 2 or 0 to pi restrictions, it's not going to work there either. So this doesn't make sense because the very first question is, if my x value is the square root of 2, which is way out here somewhere, not in the reach of the unit circle, what is my arc length? And the answer is you can't ever get there, so you don't get an arc length. Hi, kitty. Okay. What about inverse tangent of 11 pi over 8? Okay, so once again, I'm seeing those inverses. I'm hoping to get 11 pi over 8. I do have to be careful. So if we say, all right, this went into tangent first, so it's an arc length. If I go 11 pi over 8, let's see, 8 pi over 8 lands me right here. And then pi over 8, okay, so we're splitting the top half up into 8, which means each quadrant is getting split up into 4. So if we go 1, 2, 3, so even parts there. So this is a pi over 8, a pi over 8, a pi over 8, pi over 8. So 11, so we need 8, 9, 10, 11, which puts us really far down in quadrant 3. Okay, so here's the thing, that's not a special value. So I'm supposed to be saying, okay, what is my slope? And then after I figure out my slope, I'm supposed to be plugging it into inverse tangent, at which point my question will be, given this slope, what is my arc length? So this is actually a really good one. It starts off looking like it's fairly simple, but it gets really tricky. So because it's not a special value and I can't just walk my way through, I have to think about this really carefully. So if I ask tangent for the slope, it's going to give me the slope of this line, right? But this line could actually have come from starting in quadrant 1 at this point, or in quadrant 3 at the point we were actually at. So when we give the slope of this line, I'm just going to call it m. So this is a y equals mx plus b is 0, so just that. So I would get my m, and then I would give m to inverse tangent. I would say, okay, if this is my slope, so basically if I'm on this line, what arc length are you going to give me? An inverse tangent is never going to make it around to quadrant 3. It's going to say, okay, well, the shortest distance to get to that point is right here. And if we can see some of our symmetry straight across through the origin, this has to be 1, 2, 3 pi over 8. So the answer here will be a 3 pi over 8. So again, a little bit of symmetry in the mix for that one. I really like that one.